Hi guys. So I'm going to show you something pretty interesting here with these things. The trick into is really not what you would think you have to do to make these motors do what you want to do on the output. Like either way, it's going to be more power out, but there's a way to trick them through with these north-south configurations. Figured a long time ago with the bigger motors just by hooking stuff up wrong. And like after you realize what's going on, once you get a scope and stuff like that, you can actually see what's going on and figure it out. So, and it comes with pulsing just one side of the motor, and leaving the other half not, just kind of like an alternator version, like it only fires for 50% at a time. So I have all these here. You can see kind of the configuration. Here's my pin. See, red to this coil, blue to this one, blue to this one, red to that one. It's opposite. And then this one's the same as that one, blue to red. And this one's the same as this one. Red for the first coil, blue for the second. You can see this is just that coil I used to measure the frequency, the voltage off of. It's not doing anything. That meter's hooked to the bridge rectifier right there. But I'm going to show you something right here. You can see I have it so all these coils are working together. They're pushing the rotor together in series, the way they're supposed to be. Like interacting with the magnets in front of them right here. Like a push-pull per each pulse type of thing. Nothing's fighting each other. So I'm going to start it up and we'll do some measurements. I got this current probe here on the output. I have this battery, 48.99 volts or 47.99. And the input battery's 13.1. This thing hasn't been charged in months. Should be around 13.1, yeah. So it's not going to go any lower than that. But I'm going to start it up and run it so everything wants to work together. And then while it's running, I'm going to switch one of the coils and reverse them. And you'll see what happens. But first, before I do that, I'm going to start it up, do all the measurements, give the in and outs, which I'm not sure yet, but I think there's still more on the output than the input in this first demo. But once I switch this coil around, I'll reverse it. While it's running, I'll do it and take this wire right here and put it where the black one is and put the black one where that one is. That's for this coil right here. Just this one. And you'll see what happens. And we'll do some more measurements after that. So I'm going to start it up. And I'll be taking this probe off and putting it on the input too. Right now it's on the output. Oh yeah, I'll show that it's all zeroed too. Everything's zero. The scope is calibrated. So start it up. Here's the frequency and the pulses. There's a 4.72 UF cap on the timing circuit. Right there. Flyback is what is going into the battery here. Here's the wires. Don't mess with wires, but they're all right here. All connected together right there. Bit of a spider web, but takes a bit to get going here, and then it'll be going. So this is the output current here. But we'll wait till it gets up to RPMs here and then we'll take some measurements. Just bear with me. You'll be seeing some interesting stuff with this motor. I have not showed this before. I like to do stuff so that people can I like to do it in stages so people actually learn, Like, it's important to have it so you can move all these coils around. It looks like a just hacked together motor, but it's done like that for a reason, just so it has tunability into it. Like, these coils can go in, out, sideways, within like half an inch. Either way. You can move them, like skew them, you can put them in all sorts of different angles while it's running. Same with the Hall effect. It's not on something that's like mounted solid. It's on a copper wire where I can just put it wherever I want. It stays there. It won't move until I move it again. That's important. Like, if you just have something that's fixed, you're limiting yourself. See, the battery voltage is already going up. So I don't want to turn on the big lights in here. Just hot right now, summer. So. It's getting up there pretty close to where it needs to be. It's using quite a bit of current on the input. And these are, this meter's in the 1 millivolt for 10 milliamp setting in the center right there. And that's on the yellow one here. 50 millivolt per division. On this here, this little cursor, I can measure that. Just pause it here. Then I can move this up and down, and there's a line that appears. So right now there's about 20 milliamps coming out, or 200 milliamps pulses coming out into this 48 volt battery right here. You can see it's climbing a bit. I started at 47.98. I just want to kind of leave it where it's not going to speed up too much more. And I'll start taking some measurements. Do the math on it, in and out. Try to make the video as fast as possible, but this one kind of has to run itself through. I don't want to pause it. And I'll put you on the tripod when I switch that over so you guys can see. There's 10 magnets on that rotor, and they're all north-south. So it fires 5 times per rev. If you want to figure out the RPMs, you just take the frequency there, the top number, and divide it by 5, and then times it by 60. And that'll be your RPMs. Okay, it's pretty close there now to where it's not going to pick up too much more. It might pick up a few more hertz. But I'm going to pause this, get my reading now. So it's at 15 millivolts, so 150 milliamps on the output of that right now. So I'll grab the calculator. So 48 volts right there. 48 times 0.15. 7.2 watts on the output right now. So I'm gonna move this input right here, or this to the input. Try not to knock off any wires. Right there. This is, it's backwards, I'd rather. I like that, it's easier to read the way I have the scope set up. There. That. So there. It's probably still more on the output the way it is right now. By the way it looks. So 250 milliamps on the output times 13.1. times 0.25. Yeah, 3.25. 275. So there's almost twice as much, or about twice as much coming out right now. So just unpause this and put it back to the other one here. I see the duty cycle and the waveform looks the same. There's just less current on the output with a higher voltage. So now I'm going to put you on the tripod. And what you're going to see when I do that is the motor's going to automatically reverse direction on itself. By itself. I won't be doing anything with the timing or anything. All I'm going to be doing is reversing that one coil. And it's going to be, what happens is it uses the, it like automatically uses the side of the motor that's not being used right now when I do that with the power that these other coils are using when it turns off, when they turn off. Because right now they're all in series and working together. So I'm going to take those two wires I showed you earlier and flip them around. That stupid air conditioner turned on. It's hot in here, but noisy. And the timing won't be changed. If anything, I know the current on the input of the motor is going to drop a lot when I do this, and it's going to speed up, so I might end up turning the duty cycle up a little bit just to bring the current back up to where it is when it's going this way, and then we can still do our measurements. All the motors I've ever done this to always do it. The big ones have some drastic effects too. You see it's stopping. It's going to stop and it'll go in the opposite direction. Usually it takes off when it's on back the other way. There we go. It's going the opposite way now. Here's the motor. See the back spikes, the bottom current there, it's on the output. And watch it now. You can already see the current on the input is way less than what it was before on the analog gauge. I think the frequency was around 140 hertz. You can see already what it looks like here. It's a different type of waveform. Now you'll see it as it speeds up, the output's going to get stronger. Just let it do its thing here until it's... You can see how much lower the input is now. Just turn that meter back on. It's way less than what it was before. And you can see right there. Still picking up speed. It's less though, but I'm going to turn the power up on the motor a bit so it uses more. Put it to about where it was the last time. Still less than what it was. Let's see what the scope is doing. The output power. Turn it up some more. Turn it up too much. So it's adjusted the timing a little bit to match it. You can see the current on the input is really low. The output is really coming up a lot. Because what you're seeing is that one coil is what is propelling it, and all the other ones are putting in a power output. It's not a mechanical, it's not the way to run it for mechanical power, but this is the way to do it for output, electrical output, because the input goes way down and your output is way up. So I have to wait for it to stabilize here. When it slows down, the output just keeps going up. There, it's stabilized. It's pretty close. 29 hertz. Yeah, it's pretty stable right where it's at there now. So I'll take these measurements. $350 milliamps. So 48 volts. That's 0.35. That's 16.8. And the output. I'll put this back to the input. So it's not much different. Almost the same waveform. $410. So 430 will do. That's being generous. 43 millivolts. And then you can see it's stable. The RPMs are stable. So 13.1 times 0.43 is 5.6. That's the in and out. This is in. And you see the waveforms almost identical. I'll take this one back on here and I'll put it back on the output again here. So there you can see, looks almost the same, just a little bit less current. That's just by flipping that one coil around, it switched the rotation of the motor. I did tune the timing just a little bit to get it ideally where it needs to be, and I adjusted a bit of the duty cycle on the PWM. It's almost the same where it was though. This one here, and you can see the RPMs are stable. That one coil is opposite polarity to the other ones. It's fighting itself, and that's what makes it do what it's doing here. And even the other way, it was still over unity. It still had twice the power coming out. Now it has about 3 times the power coming out. But obviously there was all the torque you want on the shaft on the other direction, the other configuration. I don't think I've showed this before. And if I have, I've never said anything about what I was doing. But I have 3 of these, so I'll be making some better videos when I have more time. I just threw these coils on here and configured it to make this demo as quick as possible. It's kind of a rat's nest of wires, but you can see there's 3 coils up there that are hooked to this bus bar, and then they're all put in series over here along with this one, and they're all in series right here. You can see I'm hooked to the positive and negative. See clearly how it is. And you see where the scope is hooked up to the positive and negative of the motor output. And that's the output voltage. See, they're really strong back spikes. You can see the current form follows the wave, like the sine wave. That's what you're seeing there. That's why it does that. That's why it's so important to have a scope. A good one that you can actually see this stuff. Doesn't have to be the best scope. It's not the best one, but it's not a shitty one either. But anyways, just wanted to share that half an hour video almost. So. And it can change a lot too, just with the configuration of the coils. Just by moving them around a bit, you can get it even better than this. I just wanted to show the effects of reversing it. You can still tune it even more yet after you do that to get better results than this even. You know, if you want to have it so that it's always like this, you might want to tune it to where it's able to put out more power. You know, you're looking at 3 times the power here. I forget what the numbers were, 5.6 on the input and like 16 on the output or something. But that's just a quick demo and no tuning. But you know, and you can do it with higher voltage outputs too. That's why now I have 300 volts of these batteries. If I want, I can do it like that. But anyways, it's a long enough video. Be more with this stuff coming up. And thanks for watching, guys. Don't be afraid to ask questions, comment.